everyone, my name is Yashasvi Sanchana and my project is Embedded System for Wildlife Tracking. So the introduction. So Embedded System for Wildlife Tracking generally aims to improve how we watch and protect the wildlife. We use special technologies with the help of embedded systems which will help us to the track the animals, wildlife animals like mammals or different birds, and also help scientists or nature enthusiasts to uh, just know and keep track on the animals, and as well as it will help the scientists to gain information regarding the behavior of different species in their natural habitat. So the purpose is to help the scientists and nature lovers in tracking and studying the behavior of animals in their natural habitat, and also to create a powerful tool that facilitates the tracking and study of animal behavior in the natural environments by deploying some smart tracking system. So the main aim of a project is to develop an innovative solution for wildlife tracking using embedded systems, so that we can track different wildlife species in their natural habitat, and also by using advanced embedded system we intend to revolutionize the way wildlife is monitored. So embedded systems are a specialized computer system that is designed to perform specific tasks within large systems. So they play a crucial role in our tracking system. They help from processing, collecting, and also the transforming the data from sensors placed on animals to the scientists, so that they can study how the wildlife animals behave. And also by integrating the embedded systems technology with wildlife conservation efforts, we can enhance our ability to safeguard the vulnerable species in our ecosystem. So these are the hardware components which we are using, which are like microcontroller sensors. We use like GPS sensors so that we can track the location of the animals, and accelerometer to know the speed of and record the animal movement, including speed, direction, and acceleration, and also the temperature, so that for monitoring the environmental conditions and identifying potential habitat or migration routes. Additional sensors like we use humidity, pressure sensor, and also proximity sensor depending on the necessity. And software components we use like Wi-Fi and GSM global system for mobile communications or satellite communications are used for tracking animals from distances. So these modules facilitate like reliable and efficient data transmission from the field to the centralized servers, and Wi-Fi connectivity enables local data transfer within the range of Wi-Fi networks, while GSM or satellite communication ensures the uninterrupted data transmission in remote and inaccessible areas. So now this is the system architecture. So this is a sequence diagram for the wildlife tracking system using embedded systems. So here the sensor block represents the various sensors connected, and the microcontroller block represents the central processing unit, then communication modules. Then this way the data is transferred from sensors to microcontroller and then to communication model, where the whole process goes on. So block diagram, here is a visual representation of block diagram of embedded wildlife tracking system. So here's how data is transferred. Here's the data flow diagram given, how the data is transferred from sensors to microcontrollers, and then it's flowed within the embedded system, which within a structured path. The data is transmitted from the communication modules, which are responsible for establishing connectivity with the external networks, and depending on the communication protocols the data is transmitted securely. So these are the functional requirements, which are tracking and monitoring animal movement. So yeah, collecting environmental data like temperature and humidity levels in the atmosphere. So by gathering all this data, all this information, we'll have a better understanding of animal behavior on certain facts like different temperatures and different humidity levels. So these are the non-functional requirements, which are like performance, accuracy, and reliability of tracking data, and safety, ensuring the well-being of tracked animals so that they are safe, and security, protection of data. The data which we are receiving from the tracking system, the data is secured or not. These are the challenges we face, like harsh weather conditions, remote locations, and limited power sources. And for solutions, we should have a robust hardware design and also energy efficient power management. So these are the benefits of a tracking system, which are like enhanced wildlife monitoring and management, and early detection of threat to animals, and data-driven decision making for conservative initiative. So the future of wildlife tracking systems and conservation technology holds promise for advancement in miniaturization and also sensor integration. These like remote sensing, wireless communication, and all these advancement will enable more effective way of monitoring and tracking the wildlife. So the conclusion, I would like to conclude by saying that embedded system for wildlife tracking has been aimed at revolutionizing the wildlife conservation efforts, so that we develop the tracking system capable of monitoring animal movements and collecting environmental data and transmitting it into the real-time data, so that we have good usage of the data, and protection we could protect the animals and preserve our wildlife. Yeah, thank you.